I love Codegarden. You guys, you are all just such amazing people. I am so glad to be back. And there's a lot of talk, so let's get started. We are standing, I am told, on the brink of an impossibly large change. We are just a few short years away from the dawn of superhuman artificial intelligence. The question of whether humanity is about to build its own successor is being debated by billionaires and technologists, and they warn of dire consequences. Listen to the experts. One famous AI researcher told a reporter that in from 3 to 8 years, we will have a machine with the general intelligence of a human being. Now, maybe that's too optimistic. Some of the predictions are a little more conservative. A different AI luminary wrote, "Machines will be capable within 20 years of doing any work that a person can do." It's exhilarating and terrifying. But there's something that bothers me. I have a sense of déjà vu about all this. That first prediction is from the great Marvin Minsky, the co-founder of MIT's famed AI lab, author of the foundational book Perceptrons. The interview was in 1970. The second quote is from Nobel laureate Herbert Simon, another pioneer in AI, one of the most cited authors in the field, to give you some sense of his influence. But you may have noticed I've had to slightly edit the quote, because he originally said any work that a man can do. Try not to judge him too harshly, though, because it was 1960 when he wrote that. So we've been here before. This is not the first time we have seen grand predictions about the thinking power of machines. This is not the first time that the people making those predictions had convincing evidence on display. And this is where that sense of déjà vu arrives for me, because I've read this story. In the late 1990s, I was a teenager. I was fascinated by computers and artificial intelligence. I was an avid reader of Wired magazine in print. Yes, I am dating myself. In one of those issues of Wired, I found an article about the work of an AI researcher working on machine creativity, Dr. Selmer Bringsjord. It talked in optimistic tones about his work crafting Brutus, an AI that could write compelling, dramatic stories. And he chaired the Department of Cognitive Science at RPI, an hour from where I grew up. Well, it's not unfair to say that article changed my life. I was fascinated with the idea of building a creative AI. So I enrolled at RPI. I joined the undergraduate program closest to that research, a computer science philosophy hybrid called Minds and Machines. And I spent 5 years studying AI in an interdisciplinary program, graduating with a master's in cognitive science with Selmer as my graduate advisor. I spent 5 years grounding my enthusiasm in the hard questions that surround intelligence. I came away more interested than I was as a teenager, but with a lot more questions. I want to share some of those hard questions with you. I want to show you some of the ways that the present reminds me of the past. I don't know what's going to happen next. I don't know if this time we really are on the brink of something momentous. But I think it's a good habit to be well-informed as we move forward. We start with a question. What is artificial intelligence? The answer is right there in the phrase. There it is. It's an intelligence that's artificial. Great. So what's intelligence? We could spend a lot of time on that question. If this were a class in cognition, I would probably spend the first week really exploring it with you all. But we only have half an hour, so please permit me to take a shortcut. We don't have a good answer. Intelligence is one of those we know it when we see it ideas that humans love to throw around. We all kind of know what we mean by it, but it resists attempts to lock down a precise definition. Artificial intelligence inherits that slipperiness. Take this definition from the EU Parliament, which we'll have in a moment. Well, I'll read it to you. AI is the ability of a machine to display human-like capabilities, such as reasoning, learning, planning, and creativity. All of those traits are slippery when we dig into them, but there is one thing there that I see over and over in our attempts to define AI: human-like. When we imagine artificial intelligence, we imagine something that thinks like we do. Often we imagine it as thinking like us, but better in every way. But ultimately, our own ability to recognize intelligence is the only tool we have. But I'll know it when I see it makes for a terrible scientific instrument. What if two people disagree? So we wrap our intuition into little tests that try to control for the messiness of humans. Like the Turing Test. We have heard a lot about the Turing Test lately, about whether systems like ChatGPT pass it, and what that means as a test of intelligence. So let's take a moment, revisit the test itself, and understand it. In Turing's paper, he proposes an experiment we could conduct, which he calls the imitation game. The game is played with 3 people: an interrogator and 2 participants. One of those participants is a man, and the other is a woman. The object of the game is for the interrogator to determine which of the participants is which. The interrogator asks the participants questions, but can't see or hear them, so voice and other things don't give the game away. Their answers have to be written down. In modern terms, we can assume they're texting. Now, the imitation game is a competition. If the interrogator figures out who the woman is, then both the interrogator and the woman win. On the other hand, if the interrogator guesses wrong and says the man is the woman, then the man wins. This is the heart of the famous Turing Test. It's a parlor game. Now, the game requires that the participants differ in some presumably fundamental way. Turing chose gender, but we could just as easily envision a game where one player is from America and the other is from Europe, and both participants are trying to pass themselves off as Europeans. Turing never gives the 2 participants names in his paper, so for our purpose, let's call the player who wants to trick the interrogator the imposter. Now, I suspect you can see Turing's next step. What happens when the fundamental difference is that the imposter is a machine playing alongside a human? Now, Turing's test is what philosopher Daniel Dennett calls an intuition pump, a way of helping us think about a challenging, abstract topic by comparing it to something we can easily picture. It's not a rigorous proof, but we can use it to help guide our thinking without needing to understand everything about the situation. Intuition pumps are common in cognitive philosophy because the mind is so complex. But we do have to be careful. An intuition pump can help us think about something, but it can also mislead us. So Turing was concerned with the question, can machines think? And he recognized the ambiguity in that question. He proposed that instead, we could ask, are there imaginable digital computers which would do well in the imitation game? Are these questions really equivalent? The Turing test is fundamentally a parlor game. Someone asks questions of 2 people in another room and tries to figure out which of them is lying. So is the imitation game a test of intelligence, or just a party game we can make computers play? And while a lot of people have held it up as a target, it's always had objectors, including Dr. Bringsjord. He wrote in 2001 that progress towards Turing's dream is coming only on the strength of clever but shallow trickery, which should be up there for you to read. There it goes. And he wrote that the human creators of chatbots have merely tried to fool those people who interact with them into believing that they really have minds. And this isn't even an issue that began with the Turing test. We've been here before. Before we even conceived of digital computers, we used a game to measure machine intelligence. Can a machine play chess? Well, in Vienna, in the year 1770, Wolfgang von Kempelen showed one that could. At the court of Empress Maria Theresa, he demonstrated his chess-playing automaton, a device that played a strong game of chess against human opponents. It toured Europe and America intermittently for more than 80 years before it was sadly destroyed in a fire. It looked like this reconstruction: a large cabinet of machinery with the chessboard on top and the chess player built into the cabinet. The player's distinctive costume also gives us the machine's modern English name, the Mechanical Turk. You may have heard that name before. I hear some sounds of recognition. It's the name Amazon uses for its Humans as a Service API in tribute to what we now know about the machine. The Turk's ingenuity was stage magic, not intelligence. The cabinet was carefully crafted to allow a human chess master to sit within it and move the pieces using the mannequin, while permitting the sort of careful inspection by the audience that a magician lets us perform to assure ourselves there's no hidden secret. There is, of course, a hidden secret. Now, despite what they had seen, those 18th century nobles who knew that a machine could play chess were wrong. Now, they had seen a machine engage in all the steps of a game of chess, but the playing of the game, that was still a task for a human mind. But we're too clever for this today. We certainly wouldn't be taken in by the promise of, let's say an AI-powered store, where you could walk in and make purchases without interacting with a human employee. It's okay. Amazon never technically said there weren't humans involved. They just didn't mention them. They're reviewing data to train the models. Now, reports estimate they're still reviewing nearly 3/4 of all purchases, but we can ignore that. It's supposed to go away eventually, right? Von Kempelen intended to deceive his audience. It's clear from the careful show he made of hiding the human element in the Turk's function. His real goal was to show his skill at the court of the Empress. And for that goal, building an intelligent machine and building a convincing illusion both succeed. He got what he wanted. We're still talking about him today. And speaking of today, this brings up another question. What happened at the end of 2022? In December of 2022, there was a sudden spike in AI interest and investment, which continues today. If you look online, the answer is obvious. OpenAI released ChatGPT, which was immensely more capable than any preceding system. But that's not quite true. I'm not going to claim that ChatGPT was not released then. I am not trying to make you doubt your sense of history. But the context is a little bit wrong. ChatGPT wasn't a leap forward in technical capability. ChatGPT is, at its core, a large language model, an LLM. And to make sure we are all up at a common baseline, I'm going to give a simplified summary of what that means. So please forgive the simplifications. The core task of an LLM is to predict the next word in a sequence. And we have known how to build neural networks that carry out this sort of task for decades. But the training data is a limiting factor. Humans need to provide annotated examples, evaluate the quality of the model's results, or both. And there are diminishing returns. In general, it takes exponentially more data to make linear improvements in models this way. The models hit a soft wall where it's still possible to improve, but every small increment requires prohibitively more data than the last. This wall created a practical limit on what neural nets could achieve and made other forms of AI more attractive for many tasks for a long time. But there have been breakthroughs in recent years. One of them came in 2009, when 3 Stanford researchers developed a way of using GPUs to massively parallelize the processing of this training data. This approach sped up the training process immensely, and complex models benefited more. The most complex model they tested ran more than 70 times as fast, finishing a training that had taken over 34 hours in just under 30 minutes. Another breakthrough came in 2017 with the development of the modern transformer architecture, the T in GPT. Now, unlike the previous models, which required humans to evaluate the quality of the results at every step in training, these new transformer models could do most of their training without any human intervention at all, and delivered a similar quality of results. Taken together, these two changes made a head-on assault against that soft wall possible. All you would need is an enormous amount of linguistic data. So hey, all that stuff you posted online really did advance science. Great job. And this is all amazing. This is amazing. I have been watching this process unfold over the last decade with bewildered enthusiasm. This was all inconceivable when I graduated in 2004. With every larger data set, the model has become capable of producing longer and longer pieces of coherent-seeming text. From 2018 to 2020, OpenAI released 3 successively more powerful versions of GPT and followed them up with specialized source code and image-generating models, Codex and DALL-E. And these are all fascinating advances. But look at this, none of them caused more than a minor fluctuation in the public eye. And that brings us back to the question, what happened at the end of 2022? Well, ChatGPT happened, of course. But ChatGPT wasn't a larger model than GPT-3. It wasn't fundamentally more capable. What it was is a model that had been trained to be conversational. And that training took the form of humans, writing scripted interactions between a hypothetical AI assistant and its user, and feeding them in as training data. And then more humans, lots of humans, evaluating its responses for how well they played the part. I think von Kempelen would have recognized the approach. It's why the automaton had a human mannequin as part of its design. When something appears person-like to us, we extend a sort of recognition to it. We assume it's a person until proven otherwise. We can't help ourselves. We see personness everywhere. We can tell you what a car is feeling. We can put a pair of eyes on something and instantly give it a personality. Oops. Well, so what happened at the end of 2022? OpenAI dressed their technology up to look more human. Our minds did the rest. So, does ChatGPT pass the Turing test? Well, I don't know. The Turing test is conducted with the assumption that the interrogator and the imposter each want to win. There we go. But ChatGPT sidesteps this. It engages us in a way that appeals to our desire to see another mind looking back, but it isn't trying to fool us. Just ask it. It's all too happy to remind you that it is an AI assistant and cannot have opinions or be relied upon for facts. It's so eager to remind us what it is that it's almost impossible to administer the test as Turing describes it. Then again, that stage magician is all too happy to show you that there is nothing up her sleeve, and I am not sure that makes her more trustworthy. So let's ask instead, if ChatGPT does pass the Turing test, does it matter? This question matters more than whether today's models can pass the test. This is the question of whether it's the right test. 200 years after von Kempelen awed Viennese nobility, there wasn't a question of whether a machine was capable of playing chess. The problem of making a computer play chess was tackled by many of the pioneers of artificial intelligence, and Claude Shannon explained why at the very dawn of AI research. In a 1949 paper, he wrote that chess is considered to require thinking for skillful play. So a solution of this problem will force us either to admit the possibility of mechanized thinking or to further restrict our concept of thinking. In other words, either it'll prove machines can think or we'll figure out something about what thinking is. Alan Turing developed the first chess puzzle solver in 1950. By 1952, the Bernstein chess program could play a complete game of chess. It took 8 minutes per move, and it was easily defeated by a human chess master, or a 10-year-old, but it was praised as playing a passable amateur game. It was still a far cry from what von Kempelen had shown off, but there was no trickery. The march forward had begun. In 1997, IBM's Deep Blue supercomputer defeated then world champion Garry Kasparov in a 6-game match that made headlines. That's less than 50 years from the first ever chess program. But Deep Blue didn't spark an AI revolution, despite IBM's best attempts to capitalize on the publicity. It was impressive, but it left people with an intuitive feeling that whatever intelligence was, this wasn't it. After the match, Kasparov could give interviews. Deep Blue could only play chess. In 2022, the story of a chess master defeated by the chess engine built into his exercise machine was just an anecdote in a larger story about chess. A low-end phone can now outplay Deep Blue, and it just doesn't matter. But we got something out of it. Look back at Claude Shannon's reasoning. If we can solve chess, we have to either admit the possibility of a mechanized thinking or further restrict our concept of thinking. Well, we solved chess, and in doing so, we learned a lot about our concept of thinking. Solving chess taught us what chess doesn't include. As we solved it, the limits of the approach we used became apparent. Because chess has well-defined rules, we could ignore the challenges of translating between ambiguous reality and abstract logic, and focus only on the set of hard problems that were left. But with those hard problems solved, our attention has to come back to the issues chess let us ignore. We don't always know what our options are. We don't have a clear representation of the state of the world. We can't always, or even usually, predict the outcomes of our actions. Getting close to the goal exposed the limitations of the goal. And whether we have passed the Turing test or not, we are now getting close enough to it that its limitations are beginning to show. So like we did with Shannon and chess, we should start looking at Turing's original justification. He wrote that the question and answer method seems to be suitable for introducing almost any one of the fields of human endeavor that we want to include. We don't want to penalize the machine for being unable to shine in beauty competitions, nor penalize a man for losing a race against an airplane. And there's an intuition that he's capturing here. Intelligence is an abstract thing. It's applicable across domains and across fields, but it's not at the heart of everything we do as humans. Running a race is not a form of intelligence. If it were, we'd need to consider our cars super intelligent. But solving a theorem, writing a poem, telling a joke, those are all in bounds for Turing. Turing's test centers language. And through language, we can ask someone to demonstrate a breadth of understanding. And Turing clearly intended that. In his paper, he has examples of asking the test participant not only to write a poem, like we asked GPT to do, but to justify the choices of metaphor within it, and argue against the interrogator when he suggests an edit that would make it worse. There is a lot to recommend this view. We engage with other humans through language alone all the time. When we read a book, exchange email, chat on the internet, all these interactions take place in the medium of language. We even carry out little simplified versions of the Turing test in our day-to-day life. Was that email you just got from a person or an automated system? In fact, I think that simplified version of the Turing test has eclipsed Turing's original test. Look at the difference between the test Turing presented in the paper, call it the original Turing test, and the Turing test as we frequently imagine it, the common Turing test. The common Turing test seems to have a much simpler setup. There are only two participants, the interrogator and the imposter. And the imposter passes if the interrogator says, yeah, that looks human to me. When people say that ChatGPT passes the Turing test, this is almost always the version they mean. After all, in Turing's version of the test, you just need to ask, are you ChatGPT, for it to give itself away? So Turing's test is intended as a proxy for the question, can a machine think? The common Turing test is a proxy for Turing's original test that's more convenient to conduct. But does it mislead us? Well, again, we've been here before. In the mid-1960s, Joseph Weizenbaum built a program to explore computer-human communication. And to avoid needing to encode information on a wide range of topics, his most famous demonstration was modeled on a Rogerian psychotherapist, someone who listens to their patient and asks lots of reflective, probing questions, but never introduces new information. Weizenbaum called that script Doctor, and the program which ran it, Eliza. That latter name stuck. Eliza was intended to give the appearance of communicating in English, but Weizenbaum had no illusions of its intelligence. He wrote, "I was startled to see how quickly and how very deeply people conversing with the doctor became emotionally involved with the computer, and how unequivocally they anthropomorphized it. This was clear evidence that people were conversing with the computer as if it were a person." Eliza, in her role as doctor, employed some of the same tricks we see at play today. Her script is so rigid that she could hardly attempt the original Turing test. Paradoxically, in some recent tests, participants believed Eliza must be human because an AI wouldn't be that unhelpful. But the common Turing test is easy to win as long as the interrogator wants to believe. It's not a competition anymore. The interrogator doesn't have a way to win. The original motivation of the Turing test is to replace "I'll know it when I see it" with something more amenable to analysis. But when we take that competitive structure away, what we have left is "I'll know it when I see it." Eliza, like her great-grandchild ChatGPT, was built to excel at the common Turing test. They demonstrate that what we really learn from that diluted form of the test is that our intuitions are easily led. We walk into the performance prepared to believe. It's no surprise when we do. And this isn't a judgment against these systems or their creators. We can enjoy the theater of a stage magician levitating. It's only a fraud if she asks us to invest in her anti-gravity startup. Now, as for the original Turing test, my intuition is that it's still an interesting challenge. In its adversarial form, we are still some distance from passing it, and we still have a lot to learn in trying to overcome it. But the common Turing test, I don't think it has anything to offer us. And even the original test is liable to reach its limit, where we find that our advances have less to do with building a more intelligent machine and more to do with exploiting the ways in which we recognize minds in our fellow people. We need to remember that, like chess, the Turing test is not the goal. It's a useful proxy, designed at the dawn of AI to be easier to study than the full ambiguity of our minds. When we outgrow it, it's time to move on. One limitation we can already see in the Turing test is that there's no place in it for action or planning. While chess's actions are abstracted, they're still action. The chess player is making incremental, opposed progress toward a goal. The imitation game intentionally excludes any action that can't be carried out entirely in conversation. A poem or a math proof can be requested, but it's out of bounds to interact with anything tangible. It's not a compliment when we say another person is all talk. Maybe it's not a good standard for AI either. So I come back to the grand predictions we started with, and the question, are we at the brink of something new? Well, on that front, history's optimistic. Von Kempelen's crafting skills also produced one of the earliest devices capable of simulating human speech. The AI boom of the 60s never fulfilled Minsky and Simon's ambitions, but it gave us the fundamentals of computer science, including classic search algorithms and the linked list. Our current push is very likely to develop something of use. The questions are around how we'll use it. And in that question, I fear that the image of a superhuman intelligence is more of a distraction than a legitimate concern. It creates something to focus on that isn't quite here yet, an uncaring, godlike machine, and asks us to worry about that hypothetical risk instead of the threats we can already see. And there are threats. The rush to adopt LLMs into everything has shown significant limitations. LLM-driven search results confidently give us plausible but false answers. LLM-based customer service chatbots confidently promise non-existent discounts and dispense incorrect legal advice. In a world where we are already working to mitigate the effects of intentional lies in our media and politics, LLMs give us a scalable source of plausible untruth, systems that can't lie to us because they have no notion of what truth is. And even if they did, the massive web scrapes that produced them swept up lies, conspiracy theories, and just well-intended misconceptions with no human oversight. ChatGPT is an engine for predicting the next word in a sequence. It does not know what color the sky is, only that the phrase "the sky is" continues with blue far more frequently than green or Spanish. There are many people who believe that somehow in that statistical relationship connecting those words, the model acquires a true understanding. But I can't count myself among them. I'd like to ask you to close your eyes for a moment. You're aware of your body. You are aware of the sounds around you, the warmth of this room, the thoughts running through your own head. And that awareness prompted Descartes' famous assertion, "I think, therefore I am." If I'm aware of myself thinking, then whatever it is that's aware must exist. So open your eyes and look around you. Every other human in this room, every other human that exists has that inner experience. And we don't know how. We don't even have a way to prove it. The only awareness we can ever experience is our own. We can see the evidence of their thoughts, but not their inner consciousness. I believe we might someday build a machine that has that awareness, but I don't think it's our ability to organize symbols into words and sentences that gives it to us. And I have suspicions of things I think might be involved, but they're no more than guesses. If I'm right, then the Turing test will never quite be convincing, because there's something else about us that we do. And in the process of breaking that test, we'll find a new, better one to aim for. When Weizenbaum built ELIZA, he knew he wasn't building intelligence. He wanted to undermine the arguments of machine intelligence by building a clever trick and revealing its secret. He wrote about his motives in 1976. He said that science promised us power, but as so often happens when people are seduced by promises of power, the price is servitude and impotence. Power is nothing if it is not the power to choose. Instrumental reason can make decisions, but there is all the difference between deciding and choosing. Algorithms can decide. So can flipping a coin. The power of choice, deciding with intention, that's still ours. Algorithms can decide, but we choose where to use them. We choose which consequences are acceptable and which are not. And I hope we make wise choices. Thank you.